Hello everybody, welcome to my next video. Today we will be talking about the numerical problems in fourth chapter. Chapter 4 of class 10, we will be talking about numericals here. I will be doing this numerical in the board. The question goes like this. A man can lift a mass of 200 kg on the surface of the earth. What is the amount of mass he can lift on the surface of the earth? Here, you need to know certain thing while solving this problem. Some they say that just calculate the weight and divide the total value that you obtain by the acceleration due to gravity on the surface of moon. Yeah, that gets the answer, but you need to know what the question wants you to learn. Here I will teach you that. Look. For this numerical, I want to give you one extra concept. We can lift small stone easily, and to lift a large stone, it is hard for us. Why? To lift every object, we need to apply force equal to its weight. Small stone has less weight, so we can lift it easily. But large stone has more weight, so we need to apply more force to lift it. It means to lift an object, we need to apply force that is equal to weight of the object. Force equals to weight. Here in this question, a person can lift mass of 200 kg. It means this 200 kg mass has certain weight. Weight equals to mass into acceleration due to gravity, and this is equals to the gravitational force, because weight is the force of gravitation acting on mass of an object. So how much force he applies to lift 200 kg mass on the surface of earth, that much force he can apply on the surface of moon also. The person can apply, if the person can apply F Newton force on earth, then he can apply that same F Newton force on moon also. It means the only factor that differs the mass is the value of acceleration due to gravity. Let's see it. Okay, here I have written the given things. Here, acceleration due to gravity on the surface of earth is to be provided, and on the surface of the moon is to be provided. On earth it is 1.8, and on the surface of the moon it is 1.67. We need to find the weight of the person, mass. We need to find out mass of the object. The person can lift. Person can lift on moon. We need to find it out. Mass on moon, mm. Okay. Before that, we need to calculate how much amount of weight the person can apply on the surface of earth. We have weight of object on earth equals to mass into acceleration due to gravity of earth. Mass is 200 and acceleration due to gravity is 9.8. This much amount of weight, 1960 Newton. It means the person can lift how much weight, the person can apply how much force? 1960 Newton force. Here one thing you need to write. The person can apply the maximum amount of force, that is 1960 Newton everywhere, because it is his capacity to apply this much amount of force. So he can apply this much Newton of force on the surface of moon also. So weight of the object the man can lift on the surface of moon weight on surface of moon equals to 1960 Newton. We know weight of an object is mass and acceleration due to gravity on the surface of moon. Mass acceleration due to gravity is 1.67 equals to 1960. Or now this goes that side and it is divided. 1960 divided by 1.67. Therefore the mass, look here, you just divide the force. So it will be 1173.65, somewhat like that, kg. So how much is the amount of mass he can lift on the surface of moon? He can lift 1173.65 kg on the surface of moon. Remember a thing over here. How much force the person can apply maximum? He can apply that force everywhere in the universe. Not only on the surface of moon, everywhere in the universe. So the weight that he can lift is equal to the force that he can apply. To lift an object, we need to apply force equal to its weight. So the person can apply 1960 Newton of force. It means he can lift 1960 Newton of the load. So it is in the moon also, mass into acceleration due to gravity of moon. Then it gives the answer as 1173 kilogram on the surface of moon. Thank you. Another numerical problem here. Look, the distance between Earth and moon is 3.8 into 10 to the power 5 kilometer. And the mass of the Earth is 81 times the mass of the moon. Find the position of a point on the line joining two centers where net gravitational force is 0. It is a bit tricky question. Look here, we need to draw a diagram for that. If this is Earth and this is moon, and this is the line joining the center of the Earth and the moon, let the point P be on the line, which is x meter away from the Earth. The total distance given is 3.8 into 10 to the power 5 kilometer. Let us say it as kilometer. So the remaining will be 3.8 into 10 to the power 5 minus x kilometer. Now, the mass of the Earth is capital M. Let's say the mass of the Earth is 81 times the mass of the moon. Then, if the mass of the moon is m, then the mass of the Earth will be 81m. Because if we suppose mass of the Earth as capital M, we need to divide it by 81 times over here. So I suggest you to suppose the lower mass, so that we can multiply it by 81, then get it. It's boom. That we can do that all. Now we have all kept the things over there. Let us say that in point P there is an object of 1 kg mass. Let us say there is the object of 1 kg mass. Now the question is there where net gravitational force is 0. Many of you don't understand net gravitational force. Okay, here the difference of two gravitational force must be 0. It means the gravitational force experienced by the object at point P with respect to Earth and with respect to moon must be equal to have 0 net gravitational force. The gravitational force of Earth and this object and gravitational force of moon and this object must be equal. Okay, I will just solve it and find the value of x. So I have just written the things given over there in the question. Now the main solution is here. Okay, we have the gravitational force between Earth and the object equals to gravitational force between Moon and the object. So the formula goes in this way. Okay, or F1 equals to at, let us suppose. Then the formula for gravitational force is G capital M small m upon d square. This is also equal to, let us suppose that it is distance 1, mass of the earth, mass of the object. G, mass of the moon, mass of the object upon d2 square. The formula calculates the gravitational force. Okay. G, mass of the earth is 81 times the mass of the moon. Then we can write 81 the mass of the moon into mass of the object upon x square equals to G, mass of the moon into mass of the object divided by 3.8 into 10 to the power 5 minus x square. Now we can cancel this G. We can cancel the mass of the moon. We can cancel the mass of the object. It is 1 kg that we have written here. Okay, let's bring this x squared that side. Then it will be 81 equals to x upon 3.8 into 10 to the power 5 minus x whole square. Now, many of you might think that the distance is given in kilometer. We need to change it into meter. Look here. X is also in kilometer, this is also in kilometer. It means the distance is in kilometer. To change the kilometer distance, we need to multiply by 1000. Look here, 1000. And here also 1000. Yes, this 1000 and this 1000 cancel out. So if both the distance is in kilometer, we don't have to change it to meter because the answer comes exactly the same that we want. Okay, now taking square root on both sides. Square root on both sides. Over here, we took the square root on both the sides. So root over 81 equals to root over x upon 3.8 into 10 to the power 5 minus x. So root over 81 equals to 9 and that will be equal to x upon 3.8 into 10 to the power 5 minus x. So let us take it towards the side of 9. Then it will be 3.8 into 10 to the power 5 into 9 equals to that minus x into 9, it will be minus 9x. That goes towards the side of the x, then it will be plus 9x. So what we get is as the product is 34 to 0000 equals to 10x. So the value of x will be 3.4 into 10 to the power 5 kilometers. So the distance from the object from the surface of earth that we had supposed x kilometer is 3.4 into 10 to the power 5 kilometer or 3.4 into 10 to the power 8 meter from the surface, so from the center of the earth. Like this the problem is solved.